Let's look at de Moivre's theorem. It says if z is equal to r cosine blah blah blah, okay? So if we have a number written in polar form like this, and n is a positive integer. If I want to raise that number to the n, what do? Raise the modulus to that exponent, and then take that number up here and multiply by each one of these arguments, okay? So let's say I'm taking this complex polar number, or I should say this complex number of polar form, and I'm raising it to the fifth. Well, what do? I take this 4 and raise it to that fifth. Then I write this stuff as the cosine of 5 times this argument, 4 pi over 15. And the same thing over here, plus I times the sine of 5 times this number, 5 times 4 pi over 15, like that. What does this give me? 1024 times, what is this? The cosine of what? 4 pi over 3 plus I sine of 4 pi over 3, right? But they want us to put the answer in rectangular form. So they want me to find a value of the cosine of 4 pi over 3. They want me to find a value of this part as well. So think about where we're at on the unit circle, okay? 4 pi over 3. That is the same thing as having a reference angle of pi over 3, right? So what point does that put me at right here on the unit circle? That puts me at the point what? Negative 1/2 comma negative square root of 3 over 2. Cosine and sine. So I have 1024. 1024. What's the cosine of 4 pi over 3? 4 pi over 3. My cosine value is negative 1/2. Plus I times, what's the sine of 4 pi over 3? 4 pi over 3. My sine value is negative square root of 3 over 2. So what does that give me? If I distribute this 1024, I get negative 512 minus 512 square roots of 3 times I. Let me make sure I'm still in the view. I sure am. There we go. There's that complex number raised what? Raised to the fifth. Now, here's where putting this number in polar form really helps us, okay? Think about it for a second. If you had to do it the old-fashioned way, what would you do? You'd write this sucker out 5 times and then multiply all 5 of those, right? Well, that's going to take you a long time, a lot of board space, and so forth. So much quicker and easier if you have a polar form and use de Moivre's theorem. All right, let's look at nth roots of a complex number. The roots of a complex number, okay? How do I find the roots of a complex number? Okay, so it says basically this. If z is a number in complex, or it's a complex number of polar form, then for an integer greater than or equal to 2, z has n distinct roots of the form w of k, w subscript to k, is equal to the nth root of r, and then it opens up these brackets and it says the cosine of theta plus 2 pi n, using the wrong letter here, 2 pi times k over n plus I times the sine of theta plus 2 pi k over n. Close that off like that. And notice this part. It says for k values that start at 0 and then end at n minus 1, okay? Very, very important here. You start your k values at 0, not 1 for these. All right, then you have a real similar thing written in your notes or whatever, and it just says, what if we're doing this in degrees, okay? Then you write theta plus, instead of 2 pi, you put 360 times k over n, okay? Same thing then. All right, so let's look at an example here. We have an example here, and it reads, find the complex roots by writing a number in polar form. Write the results in rectangular form. Okay, they want us to find, for this one, the fourth roots of 625, okay? Now, what are we really doing here, okay? What if I tell you to find the square roots of 16? Well, what would you maybe tell me? You'd probably tell me what? Well, that would be 4 and negative 4, right? Because why? Those are the numbers that we square to get 16, right? So if I want to find the fourth roots of 625, they're asking us, what are those numbers that are raised to the fourth to give me 625, okay? That's what I'm basically doing here. Well, let's take 625. So they're giving us a z value. Now 625 is basically what they're doing, okay? So they're giving us z is equal to 625. Well, I could do a rewrite and I could say, okay, that's 625 plus 0y, right? 625 plus 0y. Now let's see. Let's plot that because we want to convert that to polar form first. So let's plot it. In this plane here where we have a real axis and we have an imaginary axis. Where's 625 plus 0y? On the real part, you go out to 625, right? In the imaginary part, you go to 0, or you don't go anywhere. So that's 625 right there, right? So let's find r and let's find theta for this point right here, okay? Well, what would r be? What would the length from the origin to this point right here be? How many units? 625, right? What would theta be? Well, theta could be a number of things, right? Could be 0, could be 2 pi, could be 4 pi, could be 6 pi. Well, the easiest to use is 0 radians. So what does this number look like, 625, in polar form? In polar form, a number will be what? R, which is, go ahead and write this again, R times the cosine of theta plus I times the sine of theta. That's how it will look in polar form, right? So my number is going to look like R, which is 625, times the cosine of theta, so that's the cosine of 0 plus I, times the sine of 0, right? There's my number in polar form. Now, what does it want me to do? Find the complex roots. Find the complex roots here. So I want to find the fourth roots of 625. So what am I going to do here? I'm going to use this formula right here, okay? And I'm going to say for my first root, w subscript of k, but where does k start again? K starts at 0. So my first root, we're actually going to call w subscript of 0, is equal to the nth root of r. What is n in this case? How many roots, or which roots do they tell us to find? The fourth roots, right? So n will equal to 4 in this case. So I'm going to say the fourth root of r. What was r? 625 times the cosine of theta. What was theta in this case? 0 plus 2 pi times k. What did I say my k value was right now? Times 0 over n. What did I say my n value was? 4 plus I times the sine of this same thing right here, okay? So the same thing we put there. 0 plus 2 pi times 0 over 4. Well, let's keep going with this. All right, so what does this give me? What's the 4th root of 625? What did I get earlier when I did that? 5. So 5 times, what is this? The cosine of what? That'll just be 0, right? Plus I times the sine of 0. So that gives me 5 times, what's the cosine of 0? Is it 1? Plus I, what's the sine of 0? That's 0, right? So that's just 5 times 1, or 5. That's one of my 4th roots of 625. All right, let's find the next one. For the next 4th root, what I'm going to do is say this. I'm going to have w subscript now of 1. W subscript of 1. That's going to be equal to the nth root of r. The nth root, which what did we say n was? 4, because we're taking the 4th root, right? 4th root of r. What is r? Let me rewrite that over here. R we said was 625, and theta we said was 0, right? So r is going to be 625 times the cosine of theta plus 2 pi k. What's our theta? 0 plus 2 pi times k. What is k in this part? It's now 1, right? Over n, we said n was 4, plus I times the sine of the same argument here. 0 plus 2 pi times 1 over 4. All right, so what did we get here? Well, we said that was 5, right? 4th root of 625. Now this will be the cosine of, what does this give me? 2 pi over 4? What's 2 pi over 4? Pi over 2 plus I times the sine of pi over 2. I'll keep going down, but I'm out of room here. In fact, let me make sure I'm still in view. Yeah. So what do we have? We have 5 times, what's the cosine of pi over 2? At pi over 2, my cosine is 0, plus I. What's my sine of pi over 2? Pi over 2, my sine is 1. So what happens whenever I multiply this? I get what? 5i. That's another 4th root of 625. All right, let's look at the next one. W, came up with 1 last time, W of 2, right? W of 2. What is that equal to? That's the 4th root of r. What is r again? 625. Times the cosine of theta, which we said was what over there? 0 plus 2 pi times k. What's my k value this time? 2 over n we said was 4 plus I times the sine of the same argument right here. 0 plus 2 pi times 2 over 4. All right, so what did we get? We said this was 5, right? This part right here, we have cosine of 4 pi over 4, or cosine of 1 pi, right? Plus I, sine of 1 pi. So that gives me 5. What is your cosine of pi? -1 plus I. What is your sine of pi? 0. So what does this give me? -5. And let's go with our next root. I know, let's get bored. W of what next? Or W sub what? W sub 3. Alright, so what does that give me? That gives me the fourth root of r, which we said was 625, times what? Cosine of theta, which is 0, plus 2 pi times k. What is k in this example? 3 over n, which we said was 4, plus I times the sine of the same argument. 0 plus 2 pi times 3 over 4. Same argument as that. Alright, see, I said this was 5. This is what? 6 pi over 4? What's 6 pi over 4? 3 pi over 2? I need my cosine, right? Cosine of 3 pi over 2 plus I sine of the same thing, 3 pi over 2. Alright, so what's the cosine at 3 pi over 2? Cosine is 0, right? Plus I, what's the sine of 3 pi over 2? Negative 1. So if I distribute that 5, what do I get? Negative 5i. Now, what did they tell me to find here? I'll go back to my other paper and look at my directions. They tell me to find what? The fourth roots of 625. Now, what are they? Well, what did we come up with the first one? We came up with what? 5? How about the second one? What did we come up with? 5i. What else did we come up with? Negative 5. And then we came up with what? Negative 5i. So what does that mean if these are the fourth roots of 625? It means if I take each one of these and raise them to the fourth, I will get what? 625.